Welcome. We're going to learn what it takes to make a relationship a function. Because we've talked about relationships just being ordering pairs, lining up X's and Y's together. There doesn't have to be any particular rule or method for a relationship, but for a function, there has to be a specific rule followed. And that rule is this, that every input or domain value or X value, every X value or input can be paired with only one output, range, or Y value. Remember, only one. I don't care about the Y's so much. I just care that each X is paired with only one Y. So if I was given a relationship as a set of ordered pairs, to determine if it's a function, I'm going to look along the X values. I'm going to look at 2, -7, 8, 5, 9, and 0. And what I'm doing is I'm looking for a repetition in X. Because if this 2 that went to a 3, if there was another 2 down here that went to a different number, it would not be a function. But since 2 only is paired with 3 and there's no other 2's in the X value, this -7 is paired with 8 and there's no other -7's. This 8's paired with 3 and there's no other 8's. This 5's paired with 3 and there's no other 5's. This 9's paired with 10 and there's no other 9's. And this 0's paired with 3 and there's no other 0's. Notice I have a lot of repetition in Y. I don't care about that. All I care is that this 2 goes to only one number. That's 3. I only care that this 8 goes to one number. That's 3. This is absolutely a function. Okay? But if I look at this set of ordered pairs, I have a 1 that goes to a 2, a 5 that goes to a 7, an 8 that goes to a 6, a 10 that goes to a 12, and a 5 that, a 5? A 5? I already talked about a 5. Way back here I talked about a 5. A 5 went to a 7. This 5 going to a different Y value now? You cannot do that in a function. So again, I really just scan down the X's. 1, 5, 8, 10, 5. Oh, I see a repetition in X. If that 5 goes to two different Y values, that one is not a function. Not, because the two 5's in the X place goes to different Y's. They might show it to you as a Venn diagram, or a mapping, Now a mapping, again, the first one is considered your domain, the one on the left. The one on the right is considered your range. And so as I look at this, I just want to make sure that this 2 is pointing to only one other range value. This 3 is only going to one other range value. This 4 is only going to one range value. This 6 is only going to one range. Again, I care less that I have multiple X's going to the same Y. The thing I don't want is to have a X branching out to two different Y's. This one is a function where this one is not, because when I get to this 4 branches out to two different Y's. So I kind of actually just cover up the Y values and scan down and make sure I have only one line leading away from each input or each domain value. If I do, it's a function. If I cover up this and I look down here, I notice this 4 has two lines branching out from it. It's not a function. The last way they're going to show you is graphs. Now, I didn't number these graphs, but the thing I want to emphasize is that if you go out to a certain X value on the X-axis and you look up and down, you should only ever see one point, because that means this X value, whatever it is only paired with this one Y value. This X value here, whatever it is only paired with one Y value. So as you scan across, you're looking for points that are lined up vertically. As long as you don't see any lined up vertically, it is a function. But on this one, as you're working your way across, I get to these 2 points right here, and they are lined up vertically. If 2 points are lined up vertically, then this X value has a positive Y value and a negative Y value attached to this X value. That means this is not a function. So remember, you cannot have points lined up. You cannot have a domain value in your mapping branching out to two Y values. You cannot see repetition in the X value in your ordered pairs. If you have any questions, bring them to class.